Okay, let's practice identifying the right kind of equation, the right classification when we don't know ahead of time what kind of reaction it is. So looking at these, remember what we're looking for are the reactants elements or are they compounds? Are they hydrocarbons? How many of them are there? These are important questions to ask because it lets us know what kind of reaction it is. So here I have an element plus a compound makes a compound plus an element. Looking at this, that fits the description of a single replacement reaction. I want you to pause the video and have a look at the rest of these and see if you can figure it out. And then I'll let you know what the right answers are. Okay, here I have a compound plus a compound makes a single compound. When you have just a single product, that is the definition of a synthesis reaction. Now, this is not a synthesis reaction where I would ask you to predict the product because I would only ask you to do element plus element. But it is possible to have a more complicated synthesis reaction. Number 3, compound plus compound makes compound plus compound. This is a standard example of a double replacement reaction. Question 4. Here we have a compound plus an element makes a compound plus a compound. At first I was thinking maybe this was a single replacement reaction again because it's compound plus element, but if it were single replacement, it would be compound plus element. I then notice that my element is oxygen and my compound is a hydrocarbon. Also, the two products that I produced here are carbon dioxide plus water. This is the definition of a combustion reaction. For number 5, I have a compound and I produce a compound plus a compound. At first, this maybe seems confusing until you realize, wait a second, there's only one reactant. Therefore, this is the definition of a decomposition reaction. Now, this is not a decomposition reaction I would ask you to predict the products for because it's a complicated one where the products are compounds. I would only ask you to predict the product if the products were elements. Nevertheless, this is a decomposition reaction because we start with just one reactant. These were the easy ones where I gave you the full equation to classify. But you'll also get questions like this on a test where I ask you to classify and predict and balance the equations. So here I've got lead nitrate, that's a compound. And here I've got sodium hydroxide, that's a compound. Compound plus compound. That sounds like a double replacement reaction. It is important to think about what type of reaction it is before you try predicting the products, because the type of reaction determines what products you have. Because this is a double replacement, my cations are going to switch places. This is lead 2 nitrate with sodium and hydroxide. So my positive is going to find a new partner. We'll pair up with this negative. These guys pair up. So I'm left with lead 2 hydroxide and sodium nitrate. I've classified I've predicted my products, but I also need to balance. So I'm going to need 2 sodium nitrates to balance out the nitrates, and now I need 2 sodium hydroxide so that I have the 2 sodiums and the 2 hydroxides. Go ahead and pause the video and try to reason through 7 and 8, and then we'll go through them. So here we have an element plus a compound. Element plus compound could be single replacement, but is it combustion? No, it's definitely not combustion because I don't have oxygen here. So this is going to be single replacement reaction. Magnesium is going to form ions with a charge of +2. Silver ions start with +1 and bromide ions start -1. So the magnesium is going to pair up with the bromide to make a new compound, magnesium bromide. And the silver is going to be off on its own. Be sure, as always, that those charges never make their way into your final formulas. Okay, correct formulas for compounds don't have charges in them. So in order to balance, I need 2 bromines to have 2 bromines over here, and therefore I need to also balance the silvers. With this equation, notice heat is not a compound. I'm telling you that I'm having to heat this substance, but I only have one substance that I'm starting with. This is the definition of a thermal decomposition. And I just realized I didn't actually write down that this was a single replacement. But this is a thermal decomposition. So, I'm sorry, we haven't discussed that. Thermal just means it takes place in the presence of heat, but this is a decomposition reaction. And if I'm asking you to predict the products, it's just going to split into its separate elements. So my separate elements are silver, and that's not diatomic, so I'm just going to leave it like that. And oxygen. Oxygen is a diatomic element, so it needs a 2. And to balance, I'm going to need 2 oxygens, but then that gives me 4 silvers, so I need a 4 here. We need more practice. Please pause the video and give these a shot. Here I have an element plus a compound. Therefore, this is a single replacement. This fluoride, fluorine forms fluoride ions with a charge of -1. So this is going to take the place of the chloride ion that we have over here. This is iron with a charge of +3, and it's going to stay as iron with a charge of +3. So I'm going to have iron with the fluoride, and chlorine is going to be off by itself as an element. But remember, chlorine is diatomic, so chlorine needs to have a 2 next to it. I've predicted the products, but I need to balance. So I'll balance with a 2 and a 3 to balance the fluorines with 6 fluorines on each side. And I need to balance with the chlorines, 2 and a 3. And now the irons are also balanced with 2 irons on each side. Here I have an element plus an element. So in this case, you're expecting this to be a synthesis reaction. If I give you element plus element, for you to predict the products, then it's going to be a synthesis reaction. Here, I just think about what ions they form. Potassium with a charge of +1, iodine with a charge, or iodide with a charge of -1. So those just line up exactly as they are. I need a 2 and a 2 to make this balanced. Lastly, I have a compound plus an element. So I'm starting to think, okay, this is a single replacement reaction, except then I notice that my element is oxygen and my compound is a hydrocarbon. So therefore this is a combustion reaction. And therefore my products are predetermined. I don't have to think about any ion charges or anything. It's definitely just carbon dioxide plus water. Combustion reactions can be fun to balance. This one isn't so bad, however. I need 6 carbons for carbon dioxide. I need 6 times 2 is 12 hydrogens. And therefore, let's see, 6 times 2 is 12 oxygens plus the 6 is 18 oxygens. So how do I get 18 oxygens over here? I need a 9 in front of the oxygens. So that is how you would balance that equation. And I accidentally erased some stuff. But that is how you predict the products when you're only given the reactants. I hope this helped.